This is Algebra 1, Term 4, Lesson 10, Quadratics and Data. We'll begin by going to a Desmos activity to create a model and analyze it, and then we'll come back to slides and analyze data in many different contexts, and we'll finish up with a fun activity, a GeoGebra activity, Angry Birds. So let's start with Desmos. This activity should be pretty short, 30 to 45 minutes, so probably half your time or maybe even less will be spent on this activity. As you see here, there are 9 screens. So the first screen, they will watch a video and then they will put in a number they think is too low, a number they think is too high, and then just right will be in the middle, and then they will submit. Be sure to read the teacher moves. They will give you some suggestions on how to handle this task. This is actually designed like a 3-act task, so it's extremely important that you pace your students so that they're not looking ahead to the future slides to get information that may impact some of their answers. Data here. When you get to screen 3, you're actually going to drag these pennies into this and you're going to count them up as many as they can fit, and then they'll put the pennies and then they'll change the diameter. They can make it a lot bigger or just a little bit bigger. They have to do at least 3 different circles. My recommendation is to do at least 4 because they have 4 spaces here. Maybe you do a plus sign and do a 5th one. According to their data, they don't accept entries over 9, so if kids are just going and putting more and more information in, their data is not going to be recorded, so you might want to stop them at that point. It gives you some suggestions for things to say as you circulate around your classroom while kids are filling out this data. Probably the most of your time is going to be spent on this screen because it does take some time to drag these in and to count them up, and it does tell them the number here so they don't have to count them, but yeah. Alright, when they're done with that, it's going to plot their data here along with those from their classmates. So their classmates will be in blue and their data will be in orange, and then they're going to fit it to one of these models. At this point, all of the models look okay, so that you may want to talk about this screen. There are some suggestions, a lot of suggestions under Teacher Moves about how to discuss which model makes sense and why. And if you think about how you measure area, we measure area with squares, so that might be a clue. When they use their model, they're going to make a prediction. It's going to give them an equation on this screen, and they will just type in this blank that equation, but they will replace that with the number of pennies or with the diameter of the circle. And then they will use it to guesstimate. So here's the 2 circles, and then it's got an extension, and then at the end there's going to be a video showing the reveal. So you definitely don't want to show this. You don't want them seeing this screen until they've completed the entire activity. And that concludes the Desmos activity. So it's pretty quick. We're going to move on back to the slides. This part is probably going to take you the longest. Now in the slides, you're going to be given some data, and I've given you the data in Google Sheets, and if you've never done this, you're going to be fascinated with how easy this is. The kids, if they have data in Sheets, all they have to do is highlight the columns that they want to copy. So I'm going to highlight A and B, type Control-C to copy it. This would be on a Chromebook, laptop, whatever they're using. And then they're going to go to Desmos Calculator. And when they get into their calculator, they literally just paste it, Control-V, and it will automatically plot their data. Now, just looking at the data, they probably already have a good idea here about what this is, but it does say to do a linear regression equation, so they should do that for the first screen. And they're just going to type y1 tilde mx1 plus b. They've been doing this since the very first term last semester, so this should be quick and easy for them. Correlation coefficient, graph it, do the residuals. So they're just reviewing. We are having a test in the next time we meet, so they will be basically practicing what they need to do on that test. And then they're going to answer the question, is this linear model a good fit? explain your thinking. So the shape of the graph, the correlation coefficient, and the residuals should all help them make a good decision about whether this data is best represented by this model. When they get to the next screen, they're going to use the same data, same graph they've already created, and hopefully they can see it well. If not, they should click on Zoom Fit to make that data fit the grid or fit their graph. But they will go ahead and type in y1 tilde a times b raised to the x1 power plus c. They will graph and plot the residuals. Now there is no correlation coefficient, and that's because that is only applicable for linear models, so they don't need that. But they are asked, is it a good fit to these data, and explain your thinking. One thing you might want to point out if they haven't figured it out, or if they don't mention it, is that exponential models do not increase and decrease. They either increase or decrease, but they can't do it both. So that might help them make a decision as to whether this is a good fit or not. And then the last one is quadratic. This one is new, and in standard form you'll see it's basically ax squared plus bx plus c. So if they don't already know that form, you might want to write it out without all these symbols so they can see what it actually looks like. But this is how they'll type it: y1 tilde a times x1 raised to the second power plus bx1 plus c. They will graph and plot the residuals and then answer the question, is the quadratic model a good fit to these data? Alright, and then once they've decided which of the three models, linear, exponential, or quadratic, is best for this model, then they will use that model and that equation to make a prediction for the value of y when the value of x is 2.25. And then here I'm asking for their creativity. What do you think's going on? What could this represent in the real world? So just encourage them. There's no wrong answers here, but let's see if we can make it sound plausible. Come up with a context that might fit this graph. What do you think is going on? If you had to label the x with units and the y with units, what kind of units are we talking about? What is this context? Now we have another set of data. Now before they graph it, look at it in the calculator, do any kind of analysis other than just looking at it. Ask them, which of these models makes sense for this data? Just at first glance, what are you noticing the x's are doing? What are the y's doing? Does linear make sense? Does exponential make sense? Quadratic make sense? We talked about this earlier. Remember, linear is either increasing or decreasing, but not both. Same for exponential, but quadratic can do both. Once they've done that, they're going to choose, they're going to create a regression equation. Now, they could create all three pretty quickly. They will have to type this data into the calculator. It's not going to let them copy paste. And they will analyze the residuals, make sure they've got the best model possible for these data. When they get to screen A, they will discover that there is a context about revenue for the function that they have modeled on slide 7. So this context says the revenue that is earned by a business in dollars is a function of the average price for the products that the business sells. So the question is, 1, what is x when r of x is equal to 0? That means the revenue is 0. What do those reveal in context? 2, what is the maximum revenue? So using their equation, they should see it on the graph. So they're not expected to use the equation but the graph alone if they would need to. And then finally, what is the average price of the products when the business earns that maximum revenue? So they will use points in their graph to justify these answers. It does tell them in their notes to insert work to support their answers to these 3 questions. Okay, the last thing we're going to do in this assignment is Angry Birds modeling. So in this case, we're going to go to Algebra, and you're going to see some modeling quadratics. Now it does say vertex form, but I'll tell you, I did get this to work in another form. So it's possible they all work in every form. I'm not sure. I really only tried it with this one, but if they don't remember vertex form, you could put that form on the board and have them use that for reference, but hopefully they already know what vertex form looks like. Now we already know that the pig's position, that's the one that is that's the one in green over here, is at 10, 0, and the bird's position is at 0, 0. And these are going to be 2 points on our parabola. This is a parabolic path that he's flying. And we want him to reach a maximum height of 7. So I wouldn't say anything beyond that. They should have some idea about symmetry. This would be a great time once they have done this one is maybe talk about some of the features of the graph of a quadratic, because they need these for their test tomorrow. The axis of symmetry, where do we know that is? How can we figure that out? How would we find the coordinates? And how could we use these coordinates to create an equation in vertex form? How would we do it? There's more than one way to accomplish this. Guess and check definitely works, and I did do some of that. So I suggest that they do the same. And of course, you know, a lot of them are going to pull up Desmos because they're more comfortable. So once they finish this first Angry Birds, this is the second one. Same sort of scenario. They're each very different. And they are challenging. So if your students are not able to get through all 4 of these Angry Birds modeling questions, you may want to say get any 2 of the 4 or get 1 of the 4, just whatever your time permits. And this concludes our lesson, Quadratics and Data. Next time we'll be taking our last regular assessment for Term 4. Y'all have a great day.